This is a fertilizer. No, it's not made of harsh chemicals, synthetic nitrates, or toxic additives. It's organic, and it's made of chicken feathers.
Every year, millions of tons of featherweight are discarded globally. What if this waste could become something valuable? With a naturally rich amino acid and nitrogen profile, our lab-engineered organic biofertilizer has already improved plant growth metrics by over 120% as compared to conventional chemical fertilizer. And we're not just replacing these fertilizers, we are redefining the game. Let us talk you through our innovation, Biofeathers, and what it could mean for global agriculture and sustainability.
The poultry industry is one of the largest food production sectors worldwide and produces almost 40 million tons of feather waste annually. Feathers are composed primarily of the fibrous structural protein, beta-carotene, a material that is notoriously resistant to natural decomposition because of its dense network of inter- and intramolecular disulfide cross-links, hydrogen bonding, and hydrophobic interactions. This resistance to degradation is exactly what makes feather waste such a persistent environmental challenge. A challenge that needs a sustainable solution. Our solution began with sourcing waste chicken feathers from a poultry farm. We visited the Abu Dhabi modern poultry farm and collected approximately 400 grams of discarded chicken feathers.
Then we go into the lab to produce our fertilizer. We wash and clean our feathers with water and ethanol, after which we dry cut and autoclave them for sterilization. Following that, we prepare a feather broth combining certain chemicals and distilled water. Those specific chemicals include Triton X100, L-cysteine, and sodium thiosulfate. The feather broth is then put into 11 separate flasks with 1 gram of feathers in each. Each flask denotes a specific type of chemical and its subsequent concentration. After this, we prepare the live cell bacterial system, which is a core part of our method. We raise Bacillus subtilis from a frozen glycerol stock, inoculate it with algae nutrient broth, and then put it in a shaking incubator for 24 hours. After the bacteria are ready, we start preparing stock solutions for the chemicals and their concentrations. We then mix the bacteria, chemical concentrations, and feather broth together in each designated flask and put them in a shaking incubator for 7 days. The recovered liquid, known as hydrolysate, is then centrifuged at 4,000 rotations per minute, filtered using a syringe filter, and then separated into aliquots for further testing.
And voila! We've now produced one of the world's first live cell and chemically infused biofertilizers. We're now ready to go out into farms and test our organic, nitrogen-rich biofertilizer, which also contains soluble peptides, amino acids, and sulfur compounds, which are essential nutrients for plant growth and soil health. Preliminary results from growing radish seedlings already show multiple benefits of our fertilizer over commercial variants. For instance, one of our fertilizers achieved a 50% increase in leaf length and leaf width over regrow, another liquid fertilizer, and a 70% increase for the same metrics over biohumus, a solid fertilizer. The crops that we expect to target are leafy vegetables such as spinach, lettuce, and cabbage, which are highly responsive to nitrogen-rich fertilizers. In terms of advancing our project, we already have a provisional patent from the Indian Office of Patent Processing and have already established contact with the MOCCAE. We plan to leverage this credibility to pilot our biofertilizer in the UAE first, and in the long term, we hope our project contributes to a greater awareness about the circular economy among farming communities.